4x plus y is less than or equal to 8. X is greater than or equal to -6, and y is less than or equal to 3.
Excellent. Excellent problem. So I will start with these because this is the easiest possible. And I know how to graph those. When I graph x equals -6, that is a vertical line. It is solid. So this is x equals -6. This line is just x equals -6. But this says any y, there is nothing mentioned about y, when x is greater than or equal to -6. X greater than or equal to -6. Everything here, all this area, including points on the line. For y equals 3, that is a horizontal line at 3, still solid. And I'm told anything for x, I don't care, but y must be less than or equal to 3. So y less than or equal to 3. Now at this point, I intersect green with red. When I intersect green with red, I get this. I get this. And everything in between. So these are done. But now I have to work on this. First, I write the equation for x plus y equals 8. I graph the equation. When x is 0, y must be 8. So 0, 8. When y is 0, 4x equals 8 means x equals 2. So 2, 0. At this point, I will plot these two. 2, 0. And 0, 8. And this was 3. 4, 5, 6, 7, 8. It's a solid line because of the equal symbol. This is just the line. Somewhere on the line, I'm going to write 4x plus y equals 8. It does not pass through the origin. I'm going to check with the origin, meaning that I'm checking this territory. So 0, 0, 0, 0. Yes, 0 is less than or equal to 8. So then, so this is 4x plus y less than or equal to 8. And now I have to intersect this territory with the pink one. And they do overlap. Here, 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 and everything in between. This is all 3. Or, in other words, the solutions of the system. All 3 inequalities are fulfilled only if I pick ordered pairs here, all the way, on this line, and on this line. Perfect example. Thank you very much. Anything else? Anything else? Any questions on this problem?
Nope, that was the only one in the homework with 3 of them.
Okay. Yes. So remember, the trick is if you put all 3 equations in there and you do not shade in step by step, you're not going to know where the solution is. So you graph one, you shade in. You graph the second one, you shade in. At this point, you have to stop and intersect those two. After that, you can put in the third one, shade in the third one, and now intersect the existing common area of the two plus with a new area. So you can't visualize it if you just put all three. So I'm not saying you're making that mistake. I just want to explain. If I'm writing the y, I'm writing the x, I'm graphing the x, and I'm graphing this, I don't know what, where, how, what. So I have to graph the first one and shade in. I graph the second one and shade in. Now I intersect. Then I shade in this. And I notice, oh, okay, it's this. So you have to do it step by step. Put one in, shade in. Put the second one in, shade in, but now stop and intersect. And then you can put in the third one. Very good problem. Anything else? Okay, so let's look at 6.1. Solving linear systems of 3 by 3. What is this? 3 equations, 3 variables by Gauss Jordan method. Like always, the first problem will take me forever because I have a lot to explain. But then the second and the third and the fourth will be much easier. Okay, I'm going to pick a system from your book. This is the only section in chapter 6 that we need. Let's start with 21. With the other class, I did 22. So I'm trying to avoid doing the same problem so you have as many examples as possible. X plus y minus z equals -2. This is z, sorry. 2x minus y plus z is 5. And then -x plus 2y plus 2z equals 1. I'm checking my system because sometimes I copy something else. X plus y minus z equals -2. 2x minus y plus z equals 5. And -x plus 2y plus 2z equals 1. I can't take this away. Okay. Before I explain the method, there are some preliminaries, notation, and some other explanations here. Okay. There is a way of presenting the system using a matrix. So first of all, what is a matrix? Plural matrices. And it's a very important concept, and I wanted to show you. It's already in here in the graphing calculator. See, it says matrix. So it's like other functions and all sorts of like natural log, common log, blah, blah, blah. Also matrices. Okay, so what is a matrix? It's an array of numbers. An array of numbers. So here are some examples. We use big brackets. 1, 2, 3, 4, 0, 2. What is this? It's a matrix with 3 rows and 2 columns. It's called a 3 by 2. 3 rows, 2 columns. Here's another matrix. Let's say matrix B. 1, 2, 3. This is a matrix 3 by 1. It has 3 rows and one column. And I can go on forever. Okay, what does this concept have to do with the system? Well, the system has a matrix that is the coefficient matrix of the system. What does it mean? First of all, I have to make sure that the system is presented x below x, y below y, z below z, the equal symbol below the equal symbol, and the free term on the other side. Yes, it is. So what is the coefficient system? We normally call it denoted by A. And the first column will have the coefficients of x, 1, 2, -1. The second column will have the coefficients of y, 1, -1, 2. The third column will have coefficients of z, -1, 1, and 2. All this has something to do with Gauss-Jordan method. Okay, next step, the augmented matrix, also called the system matrix, or the matrix of the system. Okay, what is that? Well, the notation is uppercase A, a vertical line, B, lowercase b this time. Okay, what's all this about? Notice that I copied a vertical line. The vertical line really stands for the equal symbol. Beyond the line, beyond the right-hand side of the equal symbol, I have -2, 5, and 1. On this side, I have the matrix of the system. I just need to copy it. 1, 1, -1, 2, -1, 1, -1, 2, 2. Once we establish this, let me give you the heads up. Well, what are we trying to do? We are trying to transform this into the following matrix using row operations. And you can say, what is this? In a minute, I'll explain. So somehow the idea is, somehow we want to change this into the following matrix. But before I tell you what it is, can I go back and reconstruct the system from here? Yes. X plus y minus z equals -2. 2x minus y plus z equals 5. And the -x plus 2y plus 2z equals 1. So when I start with a system, I can write the augmented matrix. If, for example, I don't know anything about this, but I'm given this matrix, and I see that this is augmented, I know that the equal symbol should be here, I can construct back the system. X plus y minus z equals -2, 2x minus y plus z equals 5, -x plus 2y plus 2z equals 1. And now here's my question. Assuming that I will apply some operations here and eventually get this, I would like you to read the solution for me. So we're going to change all this. This is not the equal symbol. Please do not write that this matrix equals this matrix. It's not. They're not equal. But let's suppose after these operations are applied, I will talk about the operations in a minute. Let's suppose I get here 10, 12, 14. Do I know this? No, I have no idea. This is just an example. Now,
there you go.
Say it again.
I was going to ask you to slide your paper up, but you did.
Sorry. So let's suppose I managed to get this into this form. Because we have 3 variables, we are no longer talking about ordered pairs. We are talking about ordered, of course, triples. X, Y, Z. We had before X comma Y, but now we have X, Y, Z. Can anyone looking at this system, can anyone tell us what should X and Y and Z be? If I manage to change this into that eventually, at the very end.
1.
So let's go back. Can I reconstruct the system? Yes. X plus Y minus Z equals -2. 2x minus Y plus Z equals 5. Negative X plus 2Y plus 2Z equals 1. Let's assume I just invented this. Not this part, but I invented this. The right-hand side. This is complete invention. I don't know what I'm going to get. But let's suppose I get here. What should the solution be then? Just reconstruct the system. X is? Anyone?
1.
This is the equal symbol here, right? So what do you have from this first equation? What is?
So 10, 12, and 14.
That's it. That's it. Because X plus nothing is 10, Y plus nothing is 12, and nothing plus Z is 14. X must be 10, Y must be 12, and Z must be 14. Does it make sense?
Yes.
Of course, this is not the solution. As I said, I have no idea. I haven't solved this problem yet. I just picked the problem. So, but this is an example. I don't want you to think that this is the solution. I have no idea what the solution is. Okay, so we know that now the target. The target is to apply something here and change it into this. And then I'm done. Once I get this matrix to look like this, I read X equals 10, Y equals 12, and Z equals 14, and I'm done. I go back and check. But what are these operations that I'm talking about? How do I make this into this? And that's what Gauss-Jordan will teach us. This is the method. How to get any matrix, augmented matrix, representing a system, into another augmented matrix representing another system that will immediately give us the solutions. And that's the method. But now let's talk about these row operations. By row, we mean equation. But in a matrix, they are called rows. But we know that this is an equation. X plus Y minus Z equals -2, and so on and so forth. But in a matrix, we call them rows. Okay. So only 3 operations are allowed in a matrix. 3 row operations allowed in a matrix of a system. Only 3. 1, 2, and 3. 1 and 2 are common sense. 3 we need to discuss. It will become common sense in a minute. Okay, so let's go back to my system. And let me ask you this. I don't like the way these are presented. And for some reason, I would like to swap these two. Consider this equation first and consider this equation second. Or swap these two. Put this equation first and put this equation third. Do you think the solution will change?
No.
Absolutely not. So the first row operation is swap rows. If I need to. I'm not going to start swapping them if I don't need to. I'll swap them if they make my life easier in solving the system. Okay. The second question I have. Let's suppose, and maybe I should dig up my previous lecture. So here's an equation. We decided to multiply this equation for whatever purpose. We decided to multiply this equation by -1. Do you think that doing that, we change the solution of the system, whatever that was? If we multiply or divide both sides of any equation, or any row in our case, by -1 or by 10, do you think we change the final solution?
No.
Absolutely not. So that is our second allowed operation. Multiply or divide by a row, of course, by a number that is not 0. Multiply or divide any row by a number that is not 0. That is allowed.